Hello students, how are you? I'm back again with another video. I have taken this time two questions from mechanics. One is from Newton's laws of motion and the other is from moment of inertia. These questions were asked in the morning shift of 24th January 2023 JEE mains exam. Okay, so let us start solving the first question. Coming to the first question, as you can see, as per the given figure, a weightless pulley P is attached on a double inclined frictionless surface. Note down this term, frictionless surface. And then tension in the string is. Okay. Now, how to solve these kind of questions? When you have only one string, okay, always develop this habit, what I am about to teach you. When you have a single string, take that string, draw the free body diagram, and resolve all the forces at the tip of the string along the string and perpendicular to the string. Are you getting my point? What I mean to say is, this is the string. The string is something like this. At the tips, resolve the forces along the string and perpendicular to the string. Resolve the forces at the tip along and perpendicular to the string. So this is, here it will be 4 into G into sine 60 degree. Remember the 60 degree? Okay. And here of course there will be a tension. So here no, we are not interested in the forces which are perpendicular to the string because they balance, isn't it? The component of weight will be balanced by the normal reaction offered by the inclined surface. Similarly, here also we are not interested in these forces. Here it will be m g into sine 30 degrees. Sine 30 degrees up. Since the same string is there, you will have the same tension there. Tension remains the same throughout the string. Now, remember, these are the external forces. Now apply Newton's second law. To get net force is equal to mass into acceleration along the string. Along the string. So along the string, this is more. This force is more than this. So the net force along the string in this direction will be 2 root 3, okay, minus half into G is equal to total mass is how much? 4 plus 1, 5 into 8. So you get the acceleration this way. This way when you solve, you get the acceleration. So acceleration is 4 root 3 minus 1 into G by 2. Oh, sorry, G by 10. After taking LCM, you get this. Okay. Now, coming to the tension, let us apply this free body. Let us apply Newton's second law to this point. Remember, the heavier part comes down, whereas the lighter one goes up. So the acceleration is in this direction for the block, up the inclined plane for this block. So I am applying Newton's second law to this block up the inclined plane. So you have net force up the inclined plane is T minus G by 2 is equal to mass into acceleration. And acceleration is how much? 4 root 3 minus 1 into G by 10. So therefore tension is 4 root 3 minus 1 by 5. Okay. So that is nothing but the sorry, I have to add it, isn't it? So here you can find T as, you have to put G equal to 10 here. So this will be, this gets cancelled. You have 4 root 3 minus 1, okay, plus 5. 4 root 3 minus 1 plus 5. So we have, so 4 root 3 plus 4. In other words, if you can take common, then you have this 4 times root 3 plus 1. So we have first option. I'm sorry, second option. 4 times of root 3 plus 1. Okay. There is yet another way to solve this. If you would like to solve in another manner, you can write down the equations corresponding to Newton's second law for both the blocks. Okay, and there will be two unknowns in two equations. You have two unknowns, namely A and T, acceleration and tension, and you have two equations. The first equation, if you apply Newton's second law for this block, bigger block, that is the ideal block, you have 2 root 3 g minus t is equal to 4 into a, Newton's second law. And for the lighter one, you have t minus g by 2 is equal to 1 into a. So two equations into one also. You can straight away solve t by dividing equation 1 by 2. That is by eliminating a. In anyway you'll get t equal to 4 times of root 3 plus 1. Okay. Let us move to the next question. The next question is, solid sphere A is rotating about an axis PQ. If the radius of the sphere is 5 cm, then its radius of gyration. Now students, you know how to calculate radius of gyration, isn't it? Radius of gyration is nothing but, if you denote it by k, then always m into k square will be equal to I in any situation where m is the mass of the system. Here, since it is rotating about PQ, so PQ is the axis here. So about this axis, we have to find moment of inertia. So we have to apply the what? Rule of parallel axis theorem, which states that I moment of inertia about any axis is nothing but the moment of inertia about a parallel centroidal axis that is passing through the centroid or center of mass plus mass into r square, where r is the distance between the axis and the centroidal axis. So we have mk square. Now ICM is, for a solid sphere, it is 2 by 5 mr square. 2 by 5 mr square and plus m into r square. So we have k square is equal to 2 by 5. Radius is how much? 5 centimeters square. Radius is 5 cm square, whereas small r is 10 cm square. Is it? So this will be 2 into 5 plus 100 centimeter square, that is 110 centimeters square. Therefore k will be under root 110 centimeters. Okay. So basically the radius of gyration about PQ will be actually xcm, that is missing here. So the value of x is root of 110. Root of 110. This is the answer. Okay. So thank you students for watching this. If you like this, kindly subscribe and share with your friends and relatives. Thank you so much.